All right, so in this video, we're going to dive in a little deeper. Hopefully you opened up the bubble sort scene and everything is running smooth, just as I showed you last time. All right, so this one here. So in the scene, over here, as you're moving and building, you have to be comfortable having your project, all your external files, your console showing you what's happening while you're in editor, what's happening while you're in play mode, testing your game, your experience. And when you open up a scene, here's your project, here's the scene name, here's the type of build that we're at, the type of platform, Unity version. So in the hierarchy on the left, all right, this is the name of the scene. Here's all the contents within the scene. So I made a group, and just by default, you're always going to get like a directional light source, and I have a UI going, so I have an event system. So this, I titled it miscellaneous. All it is game object create empty, and you can name it whatever you want. It's just good for grouping stuff. So put a group name, put stuff underneath it, what have you, and you drag it in and then minimize it. It's just be organized and clean, because when you have 5 classes a semester and you're jumping around and you only spend a few hours here and you jump to another class a few hours, another class a few hours, what have you, and you're back here at the end of the week, your mind's going to forget what you were doing. So spending that extra time with good naming conventions, good organization, just a clean project will make your life very easy. So that's why this stuff's miscellaneous. It's like, not really I made it. It needs to be in the scene. It's from Unity. And I'm just grouping it together so that I can minimize it and forget about it. All right, so bubble sort level is the core of everything that's happening. So I'm going to go through WebGLUser first because it's a lot smaller. And it allows me to actually show you one issue that happened with exporting over. So if I go back to the old project in 2018, if I click on WebGLUser, notice I have a click mask of WebGLUser. And actually I have so these click masks, if you notice, look at these names. If I come up here to layer, you'll notice that these are all the same names. So we have this idea of an object name, a tag of an object, and a layer of an object. All right. So every game object, if I click over here, you can think of them as large objects that are built to work really well within the Unity game engine. So we call them game objects, but a game object is still an object that was instantiated from a class. We're still within object-oriented programming, that all the conventional languages are these days. The idea is that you write a class, you write some code, maybe this right here, public class, do this, do this, do that. This is like a blueprint. This actually doesn't run. It's just your directions that are saved for you. It's your class, your abstract idea. And when you use this class in your application at runtime, it instantiates just objects of it. It constructs instances, copies of it. We call them objects because they're like the live version of the class. So think of the class as like a blueprint of a house, just a diagram. And when this is actually run in the real time, we actually build the house. We make an object. So there's just a distinction between class and object. So everything in object-oriented programming, everything is an idea of an object. It's like a distinct mathematical entity. It can contain properties, variables, and it can contain methods or types of behaviors. So we have properties, or variables, and behaviors, and that makes up the essence of an object. There's state information about it, and then there's behaviors that the object can do. So everything here in the left in the hierarchy that we see is called a game object. It's objects that have special properties, like they can appear in a hierarchy, they can contain components that are other objects, they can have a name and a tag and a layer, and they're really built well into the Unity game engine. So they're like this super special type of object that we call game objects. Now, once you understand that idea, then that means game objects are really just coming from classes, which, yes, they are. These are instantiated objects, copies of this class called game object. We just don't see it because this is code coming from Unity that Unity developers wrote. And they wrote a nice documentation, and they made a very nice API or application programming interface. It's like a whole huge library of class, a whole library of code that's already been done for you, and it's been nicely cleaned, and it's been only certain aspects of it are exposed to you that are very easy to use and very safe. And that's what they call the interface. So much like a user interface, a graphical interface, this is their interface from their code base that third-party developers like you can use. All right. And so they have a very good documentation and scripting reference. This scripting API here. All right, so I can even go search scripting. Let's search up game object. And here's game object, the base class for all entities in the Unity scenes. So this is all this code, not made for you. It's just given to you, and this is all this documentation on how to use it and call properties and methods on it. And all this stuff, I know for a lot of you, is like all very new and overwhelming, and that's why I'm just grounding you out, and you're just moving with me. And don't worry, you do a lot more coding classes. A lot of this stuff becomes very second nature to you. So each of these are game objects, are copied instances of a class called game object. Now the super cool thing with them is you can name them, organize them, put them in hierarchies, give them tags and layers, which we'll get to in a second. But they also have components. These components are classes. Well, actually, they're objects coming from classes. And in one case here, you can see mouse click raycast. There's a script, and I wrote it. And you can double click here, and it'll show you where it is in the project. And it just opened it for me in Visual Studio. So when you install Unity, Visual Studio will come along for the ride. Now, when I opened it, this is a public class called mouse-click raycaster. Notice my classes. We use camel case, meaning no spaces, all words have a capital letter, very easy to read. And for classes, capital letter to begin with. Now these are variables, and they're still camel case, but they start with a lowercase letter, so that we can very easily tell that they're a variable, a property, a field. So a variable, property, and field, everything's, you can think of these as variables. They're containers. They hold some data of different types of things. These are more complicated ones. First, we usually start with like integers or floats, which are decimal numbers, or booleans, or strings, which is just text. But these are very specific ones to Unity. And it's just for right now, just if you ever hear the word properties or fields or variables, just think of them all as variables, that it's a bit of data that's connected to a class, and each object can change that variable. They can put different values in there because each object is going to be different. It's going to have different numbers connected to it. In any case, this class is public, meaning we can reference it outside of other classes. Notice there's some public scattered about. If I hover over these things, no, it doesn't say private, but if it doesn't say public or private in front of something, by default it's private. So for example, this method is private, and these are private and public. Private means only objects that are coming from this class can recognize them, can use them. It's for data protection. It's so other classes don't manipulate objects coming from other classes. We just get a whole mess. Like, you don't want to be all your objects to be able to change everything else. You need some structure to your code. So I guess while I'm talking about this stuff, I'll just talk about these using statements. So these are saying we're using another piece of code. We're using a library. We're using code that somebody else developed. In this case, we're using the Unity engine. It's a whole block of code I just showed you in the documentation. And notice it's white, where these two are like a gray. So when you create a new script, you get a few of these using statements. These are used, become helpful quite often, so they include them. But in this current situation, I'm not actually using any code from those libraries, so they're muted gray, and I can actually just delete them. But this is white. I'm actually using it. And most particularly is because I'm doing mono behavior. So I'm saying I'm click raycaster, or mouse click raycaster is inheriting from another class called mono behavior. Mono behavior is coming from Unity engine. Mono behavior is just like an old legacy word. It's just the way that Unity engine came about over 15 years or however long they've been around. So mono behavior is the base class from which every Unity script derives, and it's class Unity engine.mono behavior. The name of it's mono behavior. It's a class, and it's coming from that Unity engine library. So this is what lets us make this script copy itself like an object onto game objects. In this case here, it is a living instance of the class, an object. We can have many of them. You can have as few or as many of the objects as you need to just have your application do whatever you need to do. In this case, I'm only using mouse click raycaster once. So there's only one object of this, as opposed to say something like the containers and the spheres and the button where there's multiple instances of them. So since this is of type mono behavior, not of game object, you can assign it like a component, a sub-object onto the game object, the main object. And each little sub-object gives more behavior, more features, more functionality to the game object. In this case, this game object called WebGLUser receives functionality from this script, or this object, this instance of this script called mouse click raycaster. And what is it receiving? It's receiving functionality that it can read in user input. I'll go through this code later. But it's basically saying that if the user clicks the left mouse button, we're going to go figure out where the mouse is on the screen, and we're going to figure out how that correlates into this virtual 3D world so that we can eventually figure out where to place that hand model. And I know a lot of these names don't make sense or anything else. I'm just doing very high level right now. I'll dive into the code later. So this functionality, allowing us to read in mouse movement, and whenever the user clicks, watch where my mouse is, look at that hand model. I'm going to click, there's the hand, boom, 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 boom. The hand is figuring out in the 3D world. In fact, in my scene view, I'm just going to press the F key, and I'm just going to position our little dev camera. Think of this camera on the scene view as like your dev view. In this on the right hand side is what the player seeing. On the left is a camera you can move that lets you see a lot more than what the player sees to help you develop. So look, as I'm clicking around, the hand model is figuring out where in 3D space it should place this hand. And if I hold down the mouse button, I get a much smoother movement, but the essence is still the same. It's just doing it, moving the hand so many times per second that it feels like a smooth movement, although in reality it's just doing this. It's just doing it so fast that your brain can't distinguish discrete individual movements, and it makes it feel like smooth motion. All that is coming from this here. In fact, I'll remove it, and look, nothing's happening. Can't click. I was in play mode when I removed that component script, that object instance of mouse click raycaster that is sitting on the WebGLUser game object as a component object. But I did all that while I was in play mode. And your changes do not get saved when you're in play mode, because you're meant to experiment in play mode. So as I unclick play mode, it returns back to where it was. But that was, you can remove a component. And you can add a component in a similar fashion. I don't want to put my UI controls on my camera base, on my user clicking object. That doesn't make sense. You try to name stuff and organize your scripts in ways that are very, very logical and easy to understand so that you can remember and other people can understand what you're doing. So I'm going to remove that, but this is an object which is acting as a component. So let's just first say this is an instance of this script. The script looks like this. This is the class. I can double click. This is what the class looks like. Notice it's inheriting from another type of class. We'll get into this later. And I dragged it onto my game object and it became a component object. It copied this script and copied it and made a separate running instance of it here, acting as a component object onto this game object. This game object can have multiple components, as many as you need to get all the functionality you need going as part of your experience. So each of these things act as a separate part, and they're all logically separated out. I'm going to remove this. That was a lot of material, and the only thing last I want to talk about is click mask. I'm not going to get into so notice it here, public layer mask, click mask, and if I double click it, it shows me that's being used here. Now, this video is getting a little longer. I'll cover it later. I just want to say that you're going to have to do this fix as well. So it's supposed to have, it's a layer called WebGLUser. And since I import into a new project, it doesn't have that layer. So we're going to have to add a new one. Layers, notice all these are there's some built-in ones, which are from Unity, and those given to you. So I'm going to say WebGLUser. Let me just see if I had the naming right. I guess it actually doesn't matter, but WebGLUser. The way I'm referencing this, you can call it whatever you want as long as you connect it. So anyway, I made the layer. I'm going to show you how to connect it in a minute. Click mask, WebGLUser. That is correct. That's good. And this is a special, when a variable is public, or yeah, let's just make it, or there's another instance called serialized field. I don't feel like getting into it right now, but if it's public, one benefit of that is it's exposed through the inspector. So this object, this copy of the class, which is sitting as a component on top of this, or underneath this, or whatever, attached to it. Whenever you have some a variable that's public of an object, it's kind of useful because it sits out in the inspector like this, and you can set it to one of the available settings. So what I could do real quick is I'll just say public int inspector integer. Notice how the writing int it just represents regular integer, but notice lowercase camel case, or lower camel case, or upper camel case, I guess is the correct way to say that. But let it compile. Well, I'm in the wrong unit. I'm going to close that one after this because that was everything I wanted to show you copying over. Let it compile. There was that little wheel down there. Now notice inspector integer 0, and I can scrub it. You can set it So instead of setting this, which you can completely do in your code in Visual Studio, sometimes when you're doing a lot of testing and tweaking, you want a whole bunch of stuff out here in the inspector. You don't want to keep going back and forth into Visual Studio, and you want to set it here. So this is really handy. I'm going to say, however I use this integer inside the object, the integer number is 567. I just wanted to show you could set it out in the inspector. And this click mask was from this layer. Just know that names on game objects are useful to like find them with your code, as well as to organize them and find them by your eye. Tags are very useful to find game objects by code when you want to find a whole bunch, like find all the enemies. I don't have enemies listed. Find the player. I've seen it common to show like enemies or trees. Find all the trees in your level. You can tag all your trees with the tag. You can create a tag, call it tree, search for everything by tag tree, and you can find all the trees and change the leaves to red, you know, if it's entering fall. Layers are dealt more with physics, how physics objects interact with each other. And that's actually what I'm looking at here. As I'm saying that with the mouse click raycaster, we're doing a little bit of a physics thing. I don't think I'm going to get into heavily in this class, but I don't want to like reference all the physics objects in the scene. I only want to reference stuff that has the WebGL user on it. All right. And we'll get into that more later. Let me just double check this quad. Yeah, and it's really meant for this. There's this big quad here, and notice how it's on layer WebGL user. So this camera is looking out, and the mouse is moving, and there's this idea of screen space versus world space. And so when your mouse is moving on the screen, on the flat monitor, there needs to be a way to interpret it where in this world, notice how the camera is shooting this, what's called a fulcrum, this kind of pyramid shape out into the world. Where in this pyramid shape should the mouse cursor be interpreted as? And that is the world space. So this idea of mouse is in screen space, but it's interacting with things in your virtual world, which are in this world space, these 3D coordinates you're looking into. And how do you figure out the connection between the two? Well, you shoot a ray out, a physics ray, a line, shooting it out from the camera wherever the mouse is, and we shoot it out far enough. This case says go 100 meters out and let me know if you hit something that's on this click mask that is on a layer called WebGL user. So wherever the mouse is, here, look at the camera preview, it'll shoot a ray out wherever your mouse is in this like square area, this representing the screen. This little thing here represents the screen. And it'll shoot a line out into the 3D world, and it's looking if it's hitting anything that's a physics object on layer WebGL user. So when you create this layer again, you need, for this quad, you need to add it on there. So now he's saying this big quad, this big invisible square, which is just up here. I've turned off the mesh render. It looks like that, but I don't want to see that. I just want this green thing represents its physics surface. So it's just it's not in the renderer. It's not being rendered to the camera, but it's being used in the physics engine. And so my script is saying, go 100 meters out from the camera. And if you hit any physics object that are on WebGL layer mask, not all of them, just this one, I want you to tell me about it, because that's where we're going to place the hand. So notice this big quad is on the layer WebGL user. And it's just a collider. It's just a physics collider. Everything else is turned off. And so if we do hit this quad, tell me the position and update the position of this cube transform. So I'm going to delete this because we're not using that anymore. The cube transform is actually an invisible cube underneath the hand. So notice that the hand model is here. And underneath here, we have a cube. I can turn its renderer back on. Notice each of these are components. Each component is a class that has much different code written in it, but they all inherit from monobehavior being able to be a component object. So I can turn that cube off. I just want you to recognize that there is a green wireframe. This represents the cube. And when you deal with physics objects, which are outside the scope of this class, you want them to be very simple geometry because they're expensive. That is why I just have a quad, very simple geometry that's invisible, and a cube that's underneath the hand object that represents the hand. Notice how it moves around the hand. It's not a perfect representation of the hand, but it more or less covers the major volume of the hand. And for our purposes, it's accurate enough. And so when and I use this cube later on to push these buttons down. So I don't want to use this hand model, which if I turn on wireframe, look at all these edges. This is a very expensive polygon, a very heavy geometry as opposed to a cube, right? So the hand is just for rendering. The hand is not part of the physics system on purpose, but it has a nice little cube that is part of the physics system. And that's why this cube moves around with the hand. And I'm using the cube to tell me when I'm pushing the buttons, because the button is just a cylinder, a very cheap piece of geometry, and the cube is a very cheap piece of geometry. The hand is expensive. The hand is just for rendering. So that's why underneath WebGLUser, which has this mouse click raycaster, we have this little canvas just at this left-handed drag. This little canvas right up here. It says left drag to use hand. If I turn it on and off, it's just a little part of the UI that was added just for WebGL. That is not added for VR. That's why there's this little UI canvas underneath there. And I'll probably have to go into UI in more depth in the next video. But there's this big physics quad here for shooting a line out from the camera, our array, seeing if it's hitting something. So where on this, and if you notice, the hand always gets placed on this quad. If I click play, because I'm using this quad, notice wherever the hand is moving, it's somewhere on the quad, because that's the physics object I'm using to shoot out from screen space into world space to figure out where I should be. Here's the hand model. Here's that little physics cube underneath it. And you actually need a camera at some point to render stuff to the screen. So there is a main camera in here. And it has its own script. But here's a camera component, a class called camera, which inherits from monobehavior, which is coming from Unity. I didn't have to write all this. In fact, even the transform, position, rotation, scale, all coming from Unity. And an audio listener. I don't have audio, but there's one audio listener in the whole scene that goes with the main camera. And if you want to put in some audio, you can. And then this WebGL camera, which I'm going to have to cover what it's doing. But I'll just end with the mouse click raycast. Using some Unity engine, another library, it's a class called mouse click raycaster inheriting from monobehavior. It has a variable of type layer mask, which is called click mask. It's public because I want to set it in the inspector. It has a variable of type transform, which is the cube transform, the cube underneath the hand, which moves the hand. It's public. I forgot how it's moving. The hand must have a little script on it too, because the cube is underneath the hand. So just remembering how I'm moving the hand with the cube. Looks like the cube should have been on a layer. Let me double check. Yeah, cube is on a layer called hand touch. So I'm distinguishing, separating between the WebGL user clicking around and when the hand is trying to interact with the buttons. They're on layers hand touch. While I'm in here, let me just click on one of these buttons and see if it's not on a distinct. Nope, it is button pushable. So while we're still here, let's just fix all these layer issues. Layer hand touch. Add layer. Layer hand touch. All right. Yep, and cubes automatically selected it. Great. Let me go down here and select one of these buttons. I think it was in here. Yeah. It wants a layer. All right. So button swap, and we're not layer UI. Oops, quite a few layers that didn't get carried over. That sucks. All right. Anyway, button pushable. Button pushable. Oh, UI. Okay, UI is built in. That's good at least. So I don't need to do that. So if I go to image, yeah, layer UI, perfect. So button swap needs button pushable. No, I don't want updates children, just this object, not image. And this one is button pushable, just that object. All right, so I've done quite a bit to see. I'm going to save it. And I'm going to go back to the previous WebGL, send output. I don't know if I'm using that anywhere. But in later videos, that stuff might need to be fixed as well. But I think we're pretty good where we currently are. All right, so I fixed a bunch of the more layers, and I just wanted to finish the script here. Right, so cube transform. Technically, if you're moving the cube, it's a child of the hand. Yeah. Oh, am I moving the parent? You know what? Bad variable name, my fault. So I'm thinking that cube transforms relating to this, but if you notice what I plugged into it was the hand. So that's why, see, I returned back to this project months later and I don't remember anything about it. And so I'm just moving through my code and I'm just trying to remember as I'm doing it. And I actually gave myself a misleading cube. It is supposed to be the cube transform. Oh, I'm hunting around for the cube. I should have renamed this later on as I started using the hand. So this is really the hand, and you can tell that because if I come back up here, cube transform, and click on what is this transform actually relating to, it's saying the hand, and this is the transform. So notice as I scrub X, look how it moves the hand back and forth. So I'm just updating the position on the transform, which is this component object. It's a class that's an amazing class. Don't even have to know about the details of it. It places stuff for me. All right. I have a vector 3, which is actually 3 floats, x, y, and z. Notice position x, y, z, rotation x, y, z, scale x, y, z. These are all vector 3s. Rotation is a different beast. You can just if we get into rotation, there is a way to convert the crazy data structures of rotation into a vector 3. So you can just assume it's a vector 3. All right. Array is coming from Unity Engine. It represents array or a line that can be drawn in 3D. Raycast hit is a data structure that comes back with information. What happens when you hit something with a physics ray? And this is the information that comes back to you. It says raycast hit. So void update. So this is private. These are private too, only accessible within the class. Void means, okay, this is a method. That's what these smooth brackets mean. These parentheses. It means stuff can be passed into it, but it's empty. There's nothing in there. But it means whatever this name is a method, a block of code that can be called many times, like a behavior. In this case, Update method is something that's being inherited from monobehavior. Inherited from another class. I didn't have to write how this thing works, but update is called every frame. Now, a frame you could think of as like a loop, an update to the computer. It's when we can loop back. Usually, if you've heard of frames or FPS, frames per second, you're thinking of video. So 30 frames per second for TV, 20 frames per second for film, 30 frames per second for internet video. How quickly is an image refreshed? So code is kind of refreshed as well. Code works in a loop. It's constantly looping on the hardware. And so this method is called as quickly as can be looped through all the code in the project. So the more complicated and bigger your code base, your application, the longer it's going to take to go through it all on the computer. So the less loops, the less frames you're going to get per second. So there's always like this trade-off, this back and forth. So the update loop is like the core of games. There's the start method, the awake method, and the update method, all coming from monobehavior that you should be familiar with. Start's only called once, right as soon as the object is copied or becomes alive, created from the class. Awake is every time it becomes awake or enabled. You can disable stuff and enable stuff, but it's still like alive. It still exists. So there's this difference between start and awake, and they're useful in different situations. And then there's update. And there's more, but let's just start with the few that make the most sense right now. An update is called as many seconds as possible based on the hardware, how strong your computer is, and how big of this code base it is. But you can think of it ranging from 30 to 60 frames per second. And it can definitely drop less, and it can definitely be more. In some games you've played, maybe there's like a little number in the corner, and it says FPS, and you see that number just kind of going all over the place. And that's how quickly the core code of that game is running per second. Normally, you only think about it for rendering purposes. You want smooth graphics, especially in virtual reality or really super high-res AAA games. Oh, I want it to be at 60 frames, 70, 80, 90 frames per second, for smooth animation. But this ideas applies to the whole code base as well. So as many times per second, 30, 60 times per second, we're checking if. Notice these curly brackets are the beginning and the end of this method. Notice a class has a beginning and an end. A method has a beginning and an end. An if statement has a beginning and an end. Other blocks of code that have a beginning and an end are like a switch statement, a for loop, a for each, a while loop. Anyway, that's what I'm thinking of right now. So an if statement checks within its smooth brackets, its smooth parentheses, this statement is evaluated to true or false. If it's false, we don't do what's in here. If it's true, we do what is in here. So notice within here is another method call. If the input class, UnityEngine.input, input is keyboard, mouse, touchscreen, gamepad, controllers, VR controllers, hand input, voice commands, input, human input coming into a machine through an interface. If input.getMouseButtonDown, it's a method, a public method that we're calling on the input class. So for the Unity Engine API, we can only call public stuff. Public properties are variables and public methods. This is a public method. And if we hover over it, it gives us some little information. It's going to return back a bool on the left-hand side. You can see that. In the smooth parentheses, that's the input. What goes into the method? Well, you need to pass an integer. That's going to be our representation of our button that we want to check if the mouse button got clicked. So input.getMouseButton, input being the class, an object of it, and a copy of that class happened. And we're going to call the method on that getMouseButton. And we're going to pass into it, here's the opening smoothing parentheses and the ending parentheses. Notice that there's two ending parentheses. This one deals with this method. This one deals with the if statement. Just like in math class, the parentheses. So we're passing in a 0 integer into this method. So a 0 represents left click, a 1 represents right click, a 2 represents middle click. That's pretty much all you need to know for getMouseButton. Now there's getMouseButton, which returns true, returns whether the given mouse button is held down. So it's only true while you're holding down the left mouse button. Otherwise, it's false. So this thing is just spitting out falses as this whole application is running. Only when the user's holding down the left mouse button is it true. Now there's also getMouseButton up and getMouseButton down and getMouseButton. So getMouseButton down is only true when you first click. So if you want to give a functionality that deals with a mouse click, you want to use getMouseButtonDown. If you want to deal with a drag, a mouse button drag, or for some reason holding down, which you can think of as like rapid fire in a video game. So think of like a handgun shot, one shot, ding, that's getMouseButtonDown. Think of like a machine gun, rapid fire, while you're holding down the mouse button, it's returning true. That's getMouseButton. And then getMouseButton up is when you release the mouse button. In this case, we're saying if you're dragging the mouse, if you're left dragging, I want to do some code. So this puts click position to just a number. This is just a default number. Vector 3.1 is shorthand for writing 1, 1, 1, or x equals 1, y equals 1, z equals 1. And there's a negative in front of it. I just do it to set it to a default value that you would never get to in any of this. All right, so from the camera, screen point to array, it's a method that shoots array out from the camera through screen point out into the world, and we have to pass in the mouse position from the input class, and we put all that information into this array variable. Then we do a check. If physics.raycast, use the uniengine.physics class, call raycast method, and you have to pass in a bunch of stuff. Pass in this array, I'm not going to go over this. This is something that pops out instead of an input. It's just a weird nomenclature if you need to pass out more than like one piece of information. Don't worry about it. I'm not covering Unity physics that much. How far out do you want this array go into the world? You usually don't want to go out to infinity because that's super expensive processing wise, 100 meters. And I only want to hit something that is on the physics layer that I have set in the inspector, in which case I called it WebGLUser. The only thing on there is that quad. So this only returns true if the user is left dragging, and he's left dragging over that quad, which I just so happen to make the quad so super big that if you're left dragging, you're going to hit it because I want you to. And there might be cases where you don't, but in the case of this game, I always want you to hit because I want to put that hand somewhere wherever the mouse is. So that hit data structure comes out. Something that comes with it is the impact point in world space from the mouse cursor in the quad. It's going to be some point on the quad. Put that into this vector 3. And remember, this is actually that hand model, 3D model. Get its position in the transform component of the hand and set it equal to this click position. And that's it. Ultimately, we update the position of this hand, X, Y, and Z. Look in the top right. Look at that position moving based on wherever the mouse is moving. And that is the essence of that script. Now, there was a lot there. And for if you're new to Unity, I know that's a lot. Don't worry. That's like probably the deepest we get into all these like new ideas within Unity. The rest will be on like, I mean, obviously we have to go through a lot of new ideas in C#, what have you, but that whole physics engine and the layers, and I just introduced you to vector 3s and shooting stuff into 3D space. It's very complicated stuff, but I thought this was the simplest little self-contained object area to talk about this hierarchy of objects here, instead, because the bubble sort level gets complicated. So I'm going to wrap that up. That's with this WebGLUser, and I didn't go into the canvas here. This little thing right here. I'm going to do a video after this just on user interface stuff.